So in this video, we want to look at limits applied to function algebra. And function algebra is something that we've learned about in our pre-calculus class. So before we look at it in the context of limits, we want to first recall what we learned in pre-calculus. So big result or big tool in pre-calculus first had to do with the sum or difference of two functions. And so what we learned was that if we take the sum or the difference of two functions and then we evaluate it at x, so we plug in some value for x, we get the same result as if we first evaluated the functions f and g at x and then added the results. Or if we took the difference between f and g and evaluated it at some value of x, we get the same thing as if we first evaluate f and evaluate g and then take the difference. So in other words, what this was saying in pre-calculus was that we can choose to add the functions first and then plug in a value, say like 2, or we can choose to plug in a value like 2 first and then add the result. We'll get the same thing. This says if you take the difference between the two functions first and then dump in a value like 2, you get the same thing as if you plug in a 2 to the two functions separately and then subtract the result. We're being told that these are equivalent or equal statements. So, and then we want to notice that this can be written more compactly as f plus or minus g of x equals f of x plus or minus g of x. And this is probably going to be a more common way to see it written. So similarly, what this was saying in pre-calculus was that you could take the product of two functions first and then plug in a number, say plug in 2. And you'll get the same thing as if you first plug in the 2 and then multiply the result. So the order isn't going to matter. Multiply the two functions and then evaluate, or evaluate the two functions and then multiply. This one says, hey, if you take f, the function f, and divide it by g, and then plug in any valid number that you want, you'll get the same thing as if you first plug in valid numbers and then divide the result. And of course, we have the usual restriction that the denominator can't be 0. So we have to include that in our thinking process. So these were tools that we developed and used in a pre-calculus class. So all the next slide does, and the next slide is the important slide for doing the homework. All the next slide does is apply the idea of a limit to function algebra. Apply the concepts of limits to function algebra. So these three statements right here are exactly the same statements as we have on the previous slide, but with the limit notation applied to them. And notice this is called Theorem 3.1. And in the homework, if it says use Theorem 3.1, this is the slide that you're being expected to apply. And in the videos that follow, I'll be using this theorem to find limits. So look at what this is saying. This is saying if you want to add or subtract two functions, and then take the limit. Notice the two functions are inside of parentheses. So if you want to add or subtract two functions and then take the limit, this is saying, hey, you can first take the limit of the individual functions and add or subtract the result, and you get the same thing. So you can add or subtract first and then take the limit, or take the limit of the individual functions and then add or subtract. This one is saying, look, if I want the limit as x goes to a of a product of two functions, I can, if I want to, take the limits of the individual functions first and then take the product of the result. So notice what's changing here is the timing of when we take the limit. Here you multiply first, then take the limit. And this theorem is allowing for us to take the limit first of the individual functions and then multiply the result. This one is the limit of a ratio of two functions. And this says if you want to take the limit of the ratio, you can still first take the limit of the individual functions and then take the ratio of the result. And of course, we have the restriction we saw in the previous slide that that limit in the denominator can't be 0, or we have an undefined ratio. The claim here in 1, and I actually kind of wish I would have ordered these differently, but the claim here in 1 is really just a special case of claim 3. So claim 3 says, hey, if you want to take the limit of a product, you can take the product of the limits. Well, this is the product of two functions. And what we want to recognize is that c, a constant, c is just some constant. A constant is a function. So this is just a special case where we say let f of x be a constant, or maybe g of x, but let one of the functions be a constant. And if we do that, then if we want to take the product of the constant times the function, we know that we can take the product of the individual limits. This will be a constant, though. This function's a constant. And in video 1, we identified that the limit as x goes to a of a constant is just a constant. So we get a constant times a limit. So that's what's going on here. The limit as x goes to a of the product of the two functions is equal to the product of the limits, but the limit as x goes to a of a constant from video 1 is just a constant. So this is theorem 3.1. In a lot of the problems that will come next, or a lot of the example videos that will come next, I will be using this theorem to find limits. And in the homework, what the expectation is going to be is that how I do it in subsequent videos is going to be the level of detail that I'm expecting from you in the homework assignment itself.